You need to know what a sequence is. What are we studying? So what is a sequence? Yeah, a common difference or ratio is very specific to arithmetic and geometric sequences, but just it has a pattern, right? A predictable next term. So you could say an ordered list. You could say a pattern, right? There's a predictable rule, like to how to find the next term. So a sequence is just a pattern. We're going to study the two specific kinds, arithmetic, which we talked about Friday, and geometric, which we're going to talk about tomorrow. How is a sequence different from a function? I heard a couple of you saying this. How is it different? So your domain is the positive integers, right? Domain is positive integers, right? Like term 1, 2, 3. There's no term -5. There's no term 1.5. A function, right? You could plug in anything that's in the domain. So you could plug in 1.26, right, into a function. So could you think of a real world example that would be better represented by a sequence? We talked about a few of them last week. I kept bringing up some real world applications. Can you think of something that would be better represented by a sequence than a function? Did you remember any of the examples we talked about? I said monthly rent, right? Usually don't pay -2 months rent or 1.5 months rent. So I was thinking monthly rent. You could also think of monthly interest. If the bank is only going to pay you interest on the month, right? There's no month 2.6. I know that when we were doing interest, we were calculating for partial years, but if it's on the month, or same thing with like a credit card bill, they only generate the interest on your credit card the start of the next month. So if you could pay off your balance, you don't have 2.5 months of interest on your credit card bill or whatever. Also thinking about like the months of the year, if there's like average monthly temperature, like what's the temperature for February? That's the second month of the year. So they're not going to do the average for 2.5 months of the year, right? So something that's by the month, right? And we're going to keep looking at some more application problems. We're going to look at card depreciation today, things like that. I talked about you could only buy like whole objects at the store. Like you can't buy like 2/3 of a dozen eggs. I guess you can buy half of a dozen because that's a 6-pack, but you can't buy one sneaker, right? You have to buy pairs of sneakers. So you either buy 2, 4, 6, or 8 sneakers. You can't buy 3 sneakers because that doesn't fit in that pattern. What's an infinite sequence? What does infinite mean? Versus finite. Goes on forever. That's going to be more important when we study series and we have to add them up, because this right here, I didn't put a ... after it. So this is just a finite sequence. I could add up these terms if I wanted to, but if it goes infinite, I can't add up all the terms because they keep growing and growing and growing. Did you know that this was the Fibonacci sequence? Those of you that haven't been here, that might have been kind of hard for you to know that this is Fibonacci, but you take 1 + 1 and get 2. 1 + 2 is 3, 2 + 3 is 5, 3 + 5 is 8. So this is called a recursive. We talked about recursive sequences last week. Recursive means you need the preceding terms to get the next term. I can't figure out the 50th term right now. I would need to find all 49 terms to get to the 50th. So recursive is not as nice to deal with. Could you see this pattern? This is 4 squared, 6 squared, 8 squared, and 10 squared. So this would have to be 12 squared. Thinking about these are patterns of perfect squares. The next one, number 7, is literally like a function. You take the number 5 and you plug it in for n. So 5 times 5 minus 2 should have given you 23. That's a closed formula. Closed is when you can take the term number. So this says term number 5. This is the sequence notation. You can plug the 5 in and generate the output. Same thing with number 8. This is another closed formula. It uses a factorial. So this was on those intro notes. What is an exclamation mark? So an exclamation mark is a factorial. Let's say you had 8 factorial. You have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And you'd have to add all those, or sorry, multiply those out on your calculator. And I showed people last week where the factorial key is. It's under the math key, and it's under the probability button. For those of you who haven't taken problem stats, here's the factorial key. It's under the number 4 slot. So math, probability, factorial. I didn't need the factorial key for this problem because 3 factorial, blurry, there you go. 3 factorial is 3 times 2 times 1. 3 times 2 times 1 is 6. Order of operations, then I take 3 times 6 and get 18. So that would be a no calculator question on the quiz. And you have to know how to read this notation. Take 3 and plug it in and generate the third term. So those of you that have been here, was the top at least somewhat familiar to you from Thursday and Friday, I hope? Tonight's homework is on, these types of problems, generating a sequence. So those of you that haven't been here, got to get going on this stuff. Number 9, this is a recursive function, just like number 5 is recursive. They wanted me to take the 2 previous terms, add them together to get the next term. So recursive, for those of you that haven't been here, is going to be a little bit confusing, but a sub k and a sub k minus 1 is different notation than up here. So if you see a sub n, it's talking about a closed formula, you plug it in and do it. But if you see k minus 1 or n minus 1, that's dealing with a list of terms where a sub k is located here in the list and a sub k minus 1 is located here in the list directly before it. So if your first term is -2, to get your next term, they want you to take -2, multiply it by 3, and then add 4. That just gives you -2 back again, doesn't it? And then if you do the same thing again, take -2, multiply it by 3, and add 4, you get -2 again. So this is just a repeating -2, -2, -2. It might not have been, but somehow it randomly came out to just -2 over and over again. Arithmetic means that it's a linear relationship. There's a common difference, just like there's a common slope for linear functions. See how this is I'm adding 1 each time? So that is arithmetic. It has a common difference of adding 1 each time. This one didn't work, adding 2, adding 3, adding 4. This one didn't work, multiplying by 2, multiplying by 2. This is geometric. We're going to talk about this one tomorrow. Closed formula. So if you haven't been here, you have no idea what a closed formula is, but this is on the notes that are 502 that you're going to need to do. So for an arithmetic sequence, the formula for an arithmetic sequence is that you take the first term, so for us, our first term is 2, and you figure out what the common difference is. I'm adding 3 n minus 1 times. So that allows me to take my first term and add 3, take my second term and add 3, take my third term and add 3. So this is kind of that general form. This is always going to be a sub 1, and this is always going to be your common difference. So that general formula is on the notes for 502, but for Thursday, you have to have this stuff down for the quiz so we can move on to series. All right, and then this was kind of a challenge one that we looked at on Friday. They give you the beginning of a sequence, and you just have to figure out, if I keep subtracting 5, will I ever get to -282? So you could do guess and check. You could use the formula and the table on your calculator. You could actually write out the formula. So the formula would be 3 minus 5 times n minus 1. Will that ever equal -282? So you would subtract 3 to the other side, divide by -5, and add 1, and you should get the 58th term. Show of hands.